as assistant professor in NB Navle Sinhagad College of Engineering, Solapur, having 8 years experience and qualification MSc Mathematics, pursuing PhD in the subject of mathematics. Next. So topic of discussion is diagonalization of symmetric matrices and quadratic forms. Now diagonalization of symmetric matrices, in last video I have already talked about the orthogonally diagonalizable. If the matrix is symmetric, symmetric means A is equal to A transpose. If we interchange rows to column, then the matrix is as it is, then we can say that the matrix is a symmetric matrix. Problem: if possible, diagonalize the matrix. Now see here, 6 minus 2 minus 1 minus 2 6 minus 1 minus 1 minus 1 5. This is A matrix. Now if you interchange rows to column, the A transpose is A itself. So this is a symmetric matrix. So we can diagonalize this orthogonally. Okay. So A is equal to 6 minus 2 minus 1 minus 2 6 minus 1 minus 1 minus 1 5. Now characteristic equation we know that determinant of A minus lambda I is equal to 0. So we subtract lambda from each diagonal elements, that is 6 minus lambda, 6 minus lambda, 5 minus lambda, and other off diagonal elements is as it is equal to 0. Now we solve this determinant. 6 minus lambda inside 6 minus lambda, 5 minus lambda, minus of minus 1 into minus 1, that is plus 1, plus, so middle term is minus, so minus of minus plus 2, the product of minus 2 5 minus lambda minus of minus 1 into minus 1, that is minus 1, and minus 1 minus 2 into minus 1, that is plus 2, minus of minus 1 plus 1 into 6 minus lambda is equal to 0. The determinant simplification. Now inside, first we simplify the inside the brackets. 6 minus lambda, 5 minus lambda, that is 6 into 5 30, minus 5 lambda minus 6 lambda, that is minus 11 lambda, minus lambda into minus lambda is lambda square, minus 1 as it is, plus 2 times in the bracket minus 10 minus 1, that is minus 11, and minus 2 into minus lambda is plus 2 lambda. So simplification is 2 lambda minus 11. Next, minus inside the bracket 2 plus 6, that is 8, minus lambda is equal to 0. Now we multiply 6 minus lambda to the bracket. 6 into 30 is 180. Now the simplification, minus 30 lambda plus 11 lambda square minus lambda cube. If I multiply lambda to each term, plus lambda, and 6, if I multiply 6 to other elements, 6 into 11 is 66 lambda minus 6 lambda square minus 6, plus 2 into 2 4 lambda, 2 into minus 11 minus 22, minus 8 minus minus plus lambda is equal to 0. Now we organize in the highest degree to constant. So minus lambda cube. Now lambda square term, 6 lambda square plus 11 lambda square is 17 lambda square, minus 30 lambda minus 66 lambda plus lambda plus lambda. If we simplify it, that will simplification is minus 90 lambda plus 180 minus 6 minus 22 minus 8. The simplification is plus 144 is equal to 0. So this is a cubic degree. Now we can find the lambdas by using calci, by considering the degree 3. Substitute the values, minus 117, minus 90, 144. You get 3 values of lambda. Otherwise use the synthetic division to find out the roots. So the factors are minus lambda minus 8, lambda minus 6, lambda minus 3 is equal to 0. In calci you can calculate this. So lambda is equal to 863 we get. So for lambda is equal to 8, the V1 is minus 1 1 0 comes, that is eigenvector. For lambda is equal to 6, v2 comes, that is minus 1 minus 1 2. For lambda is equal to 3, v3 comes 1 1 1. So these three vectors, the simplification we can see here. For lambda is equal to 8, we substitute the lambda is equal to 8 there. Now the simplification comes 6 minus 2 minus 2, 6 minus 2 minus 2, 5 minus 2 minus 3. All the off diagonal elements are as it is. Now we perform the operations. R2 minus R1, we get 0 0 0 as a row. We interchange R1 to R3 to get unit element for the first row. So minus 1 minus 1 minus 3, 0 0 0, minus 2 minus 2 minus 1. We interchange R1 and R3. Now we perform R3 minus 2R1. So the matrix becomes R1 as it is, R2 as it is. In R3, 0 0 minus 1 plus 6, that is 5. Now if we look at the equations, first is x1, second is x2, third is x3. We equate to homogeneous system, that is 0. Minus x1 minus x2 minus 3x3 is equal to 0, the equation 1. Now second row is 0. Last element is x3 related term, 5x3 is equal to 0. So from that we get x3 is equal to 0, and if you multiply minus, I will get x1 plus x2 plus 3x3 is equal to 0. From 1 and 2 we convert the relation to 3 and 4. Next, x1 plus x2 plus 3x3, x3 we have substituted as 0. So 3 into 0 is 0. So x1 is equal to minus x2. Okay, so we free x3 there by substituting 0. So x is x1, x2, x3. x1 is minus x2, x2 as it is x2, x3 is 0. So we take x2 common, minus 1 1 0, lambda 8. For lambda is equal to 8, we got v1 vector as minus 1 1 0, that is which I have written there. Next, for lambda is equal to 6, we calculate v2. Next, for lambda is equal to 6, we substitute lambda is equal to 6 there diagonally. 6 minus 6 0, 6 minus 6 0, 5 minus 6 minus 1. All other off diagonal elements are as it is. So the matrix becomes 0 minus 2 minus 1 minus 2 0 minus 1 minus 1 minus 1 minus 1. Again we interchange R1 and R3 to get unit element for the first row. Minus 1 minus 1 minus 1 minus 2 0 minus 1 0 minus 2 minus 1 after interchanging R1 and R3. Next, we perform in R2, R2 minus 2 R1. So R2 becomes R1 as it is, minus 1 minus 1 minus 1. R2 becomes 0 2 1. R3 0 minus 2 minus 1 as it is. Again in R3 we can perform R3 plus R2. So R1 as it is, minus 1 minus 1 minus 1. R2 0 2 1. R3 0 0 0. Now we write the equations. Minus x1 minus x2 minus x3 is equal to 0. 2x2 plus x3 is equal to 0. Equation 1 and 2. From 1 we can write x1 as minus x2 minus x3. Okay, and from equation 2 we can write 2x2 is equal to minus x3. From 3 we can write 2x, we can substitute x3 as minus 2x2 there. So minus of minus, that is plus 2x2. So x1 becomes minus x2 plus 2x2 there. So x1 is x2. So x we can write x1, x2, x3. x1 is x2, x2 as it is x2, and x2 is x3 is minus 2x2. From 2, x3 we can write minus 2x2. So we take x2 as a common part. So 1 1 minus 2, that is vector. Now see here, 1 1 minus 2, that is vector. Now we can multiply minus 1 to each term So we get minus 1, 2. That is required vector for lambda is equal to 6. You can multiply any, but that should be a throughout. So which I have done here. So minus 1, 2. That is vector we have considered. For lambda is equal to 3. Otherwise you can consider as it is this one. There is no problem. Next, lambda is equal to 3. We have substituted diagonal elements. 6 minus 3 minus 2 1 minus 2 6 minus 3 minus 1 minus 1 minus 1 5 minus 3. Now see here, 6 minus 3 is 3, 6 minus 3 is 3, 5 minus 3 is 2. So other off-diagonal elements are as it is. Now we interchange R1 and R3. So minus 1 minus 1 2, R1, R2 as it is, R3 3 minus 2 1. Now we perform in R2, R2 minus 2 R1, in R3, R3 plus 3 R1. So the changes in matrix is minus 1 minus 1 2, R1 as it is, R2 becomes 0 5 minus 5 for R2 minus 2 R1, for R3 minus R, for R3, R3 plus 3 R1, 0 minus 5, 7 will be the simplification. Again we perform in R3, R3 plus R2 to get echelon form. Minus 1 minus 1 2, the row 1 as it is, row 2 as it is, 0 5 minus 5. The change in R3 0 0 2. Again we can perform in R1, 5 R1 plus R2. So the changes in R1 is 5 minus 5 minus 5 plus 5 0, 10 10 minus 5 5. The R2 as it is, 0 5 minus 5, R3 0 0 2. Now we write this equation as minus 5x1 plus 5x3 is equal to 0, 5x2 minus 5x3 is equal to 0, the equation 1 and 2, and x3 as 2x3 is equal to 0. We free x3, we write for x3. Now from first equation we can write minus 5x1 is equal to minus 5x3. So x1 is x3, that is positive. Minus minus get cancel, x1 is equal to x3. For 5 from equation 2, 5x2 is equal to 5x3. So x2 is x3 after dividing 5 throughout. Now we can write x is equal to x1, x2, x3. So what is x1? x1 is x3, x2 is x3, x3 as it is x3. So we take x3 common. So 1, 1, 1 will be the simplification. So v1 minus 1, 1, 0, v2 minus 1, minus 1, 2, and v3 1, 1, 1. That simplification I have given. Okay students. Now these vectors we can write to, because this is orthogonally diagonalizable. So we find the unit vectors. How unit vectors calculated? We have seen in last lecture is calculated by its vectors magnitude. How the magnitude are calculated? And unit vector is given by vector upon its magnitude. So its norm we have to calculate. That we have calculated. Norm of v1. So v1 norm is minus 1 square plus 1 square plus 0 square. That is 1 plus 1 2 in root. And norm v2 is minus 1 square plus 2 square. That is 1 plus 1 plus 4. That is root 6. And norm v3 1 plus 1 square plus 1 square plus 1 square. That is root 3. So these are the norms of v1, v2, v3. We have to divide for this vector. That is v1 as u1. Then divide root 2, because norm of v1 is root 2. So divide minus 1 by root 2, each element by root 2, minus 1 by root 2, 1 by root 2, 0 by root 2 is 0. So that is u1, that is unit vector. u2 divide norm v2 by norm of v2, that is root 6. So minus 1 by root 6, minus 1 by root 6, 2 by root 6. That is unit vector for v2, that is u2. For u3 is unit vector for v3, v3 divided by its norm. Its norm is root 3, 1 by root 3, 1 by root 3, 1 by root 3. So u1, u2, u3. are the unit vectors from v1, v2, v3 after dividing by its norms. Now, so the P matrix, that is diagonalizable condition, is A is equal to PDP inverse. So U1, U2, U3 is nothing but P minus 1 by root 2. Write this as column wise as it is: minus 1 by root 2, 1 by root 2, 0, minus 1 by root 6, minus 1 by root 6, 2 by root 6, 1 by root 3, 1 by root 3, 1 by root 3. So this is P matrix, and diagonal matrix is nothing but of eigen values. That is, diagonal place the values 8, 6, 3, and other off diagonal elements are 0. Just we have to calculate here P matrix, because this is symmetric matrix, so that we have calculate the unit vectors. Otherwise v1, v2, v3 we put for P is equal to in matrix v1, v2, v3, and D is nothing but the diagonal entries of eigenvalues. Other elements are zeros. Next, the Cauchy-Squarz inequality. For any vectors u v in V, the Cauchy-Squarz inequality gives norm of u comma v, inner product of u comma v, as less than or is equal to norm of mod of u comma v is less than or equal to norm of u into norm of v. This is the Cauchy-Squarz inequality. And triangle inequality. For u and v, in V, norm of u plus v, you can write less than or equal to norm of u plus norm of v. This is triangular inequality. For objective purpose, you can consider. Now, quadratic form. A quadratic form on r raised to n is a function q defined on r raised to n whose value at a vector x in r raised to n can be computed by an expression of the form q of x is equal to x transpose ax. Now students, we know that x is nothing but x1, x2, x3, if 3, if 2, x1, x2, and its transpose is nothing but, because x is a column vector, so x transpose is row vector, where A is an n by n symmetric matrix. The matrix A is called the matrix of quadratic form. So quadratic form definition is q of x is equal to x transpose ax, where x is unknown matrix, that is x1, x2, x3. The simplest form of non-zero quadratic form, if a matrix is identity matrix, that is A is equal to I, then q of x is equal to x transpose ix, that is norm of x square. So quadratic form is nothing but for identity matrix, that is norm of x itself, norm of x square. Next, how to write the quadratic form. For x in R3, let q of x is equal to 5x1 square plus 3x2 square plus 2x3 square minus x1 x2 plus 8x2 x3. Write this quadratic form as x transpose ax. Now students, listen here. The coefficients of x1 square, x2 square, x3 square, so on, we can write the diagonal elements. That is 5, 3, 2 are the diagonal entries in the matrix of A, and other elements we can write. Now see here, diagonal entries are x1 square, x2 square, x3 square, that is 5, 3, 2 we have written there. Now see here, the off diagonal entries, the first or second element stands for x1, x2, and first row third element stands for x1, x3. Now see here, x1, x2 is minus 1 there. So the other off diagonal elements we have to put for the upper part and lower part of the matrix. So we have to divide that by 2. So minus 1 divided by 2 is minus half. That is x1, x2 minus half. Now there is no x1, x3 term there. So we have to put there as a 0. Next, the second element of second row is x2, x1. x1, x2 is same as x2, x1. Again, that is, this matrix is symmetric matrix. So we can write minus 1 by 2. And 3 is already we have written. 4 is comes, the 4 place is nothing but x2, x3. Second row, third column. second row third element. So second x2 x3 x2 x3 element is 8, so we have to divide it by 4, divide it by 2, so the simplification is 4. 8 by 2 is 4. Next, now third third row first element, that is x3 x1. So x3 x1 is there is no term x3 x1 here, so we have to write there as 0. Now x3 x2, x3 x2 is same as x2 x3, so the coefficient is 8, we have to divide it by 2, that is 4, and the diagonal elements 2 as it is. So once again students listen here, the diagonal entries are x1 square, x2 square, x3 square coefficient, write it as it is the coefficients, and other coefficients we have to write divided by 2. So x is nothing but x, this is 3 by 3 matrix, so x is nothing but x1 x2 x3, and its transpose column vector transpose is row, so we have written there x transpose as row x1 x2 x3. Okay. Next, let x is equal to x1 x2, the column vector. Compute x transpose ax for the following matrices. The given matrix A is 4 0 0 3, and the other B matrix is A is equal to 3 minus 2 minus 2 7. Now x transpose ax, this is x1 x2 x, we have written x transpose is row x1 x2, the A matrix 4 0 0 3. Now we multiply, 4 into x1 is 4x1, 0 into x2 is 0, so 4x1 first row to the column, second row to the column, 0 into x1 is 0, 3 into x2 is 3x2. Now first element to first element of the column, second element to second element of column in the multiplication. X1 into 4x1 is 4x1 square, and x2 into 3x2 is 3x2 square. So 4x1 square plus 3x2 square is quadratic form. Next, x transpose ax, x transpose is x1 x2. The next matrix is 3 minus 2 minus 2 7, x is x1 x2 column way. So 3x1, the matrix multiplication, 3x1 minus 2x2 minus 2x1 plus 7x2. Now we multiply x1 to the 3x1 minus 2x2 plus x2 to minus 2x1 plus 7x2. So 3x1 square minus 2x1 x2 plus of x2 minus 2x1 is minus 2x2 x1 plus x2 of 7x2 is 7x2 square. Now rearrange, 3x1 square, x1 x2 x2 x1 are same because this is symmetric matrix. So minus 2x1 x2 minus 2x1 x2 is minus 4x1 x2 plus 7x2 square. In other way we can convert the matrix form to quadratic form, and quadratic form to matrix form we can write by both the way. Example 3. Let q of x is equal to x1 square minus 8x1 x2 minus 5x2 square. Compute the value of q of x for x is equal to minus 3 1, 2 minus 2 and 1 minus 3, the column vectors. Now q of x. What is q of x? x1 square minus 8x1 x2 minus 5x2 square. Now for first vector we find out the values. Now x is nothing but x1 x2, we know that. So x1 is minus 3, x2 is 1. So we substitute x1 as minus 3, x2 as 1. So minus 3 square minus 8, x1 minus 3, x2 1 in the multiplication, minus 5 x2 square, that is 1 square. If we simplify, the simplification is 28. Next, for the second vector 2 minus 2, we substitute x1 is equal to 2, x2 is equal to minus 2. 2 square minus 8 into 2 into minus 2 minus 5 minus 2 square. So 4, 2 square is 4, minus 2 square is also 4. So if we add these things in the algebraic addition plus minus, the simplification is 16. For last vector 1 minus 3, We substitute x1 is equal to 1. The first place is x1, second place is x3, x2, that is minus 3. 1 square minus 8, 1 minus 3 minus 5 minus 3 square. Minus 3 square is 9, 1 square is 1. If we simplify, we get the magnitude as minus 20. So q of minus 3 1 is 28. Q of 2 minus 2, that is 16. Q of 1 minus 3 as minus 20. Okay students, so this is the simplification for quadratic forms. Definitely the examples is asked on this bit. Try to understand clearly. If you have any problem, you can ask me. Thank you.